Hey guys, it's Miss Gephardt, and we're going to try notes a little bit different this time, so be prepared in that there's not going to be a ton of writing. There's just going to be a lot of explanation. So make sure you're kind of taking notes as you feel comfortable, maybe through pictures or, however you want to do it. But we want to make sure you're actually getting down the explanation over just writing exactly what I write. So the notes that we're going to cover are going to be on the law of conservation of mass. And so what this is kind of pulling together how we have reactants and products and how a chemical reaction would actually occur. All right, so instead of essential questions, these are the essential vocabulary words. So when you finish this, you need to make sure you understand what these terms mean. If you don't, you go back through and you investigate them. So what is a chemical reaction, reactants and products, what is a chemical equation, what are subscripts and coefficients, and of course then what is the law of conservation of mass. As a side note, you might see this written as the law of conservation of matter. Mass and matter, they go back and forth. Sometimes it depends on the test or whatever. So just be familiar with that. All right, so the first thing we want to talk about is what a chemical, we're just kind of reviewing what a chemical reaction is. And of course, you guys can definitely see the fireworks display that you guys are probably very familiar with from when we talked about chemical reactions. But just remember, we have elements and compounds. They come together and we have something new that forms. So that's the baking soda and the vinegar, and it comes together and we get this gassing and this bubbling and stuff like that. In the example of something like these fireworks, we've got things mixing together that then produce these beautiful colors. So that is a chemical reaction. And when we do the law of conservation of mass, we're talking about a chemical reaction. All right, so reactants and products, just a quick review, and we all remember this, but the reactant is on this side of the equation, and the product is on this side of the equation. So we have this skinny little bird. The skinny little bird eats the worm. Therefore, we have the big bird now. So reactants are on the left side. The arrow is pointing to the products. All right, a chemical equation. So as a refresher on chemical equations, that's taking, just kidding, that's taking, we have these two elements. We're going to add them together and they're going to form a compound. And this entire thing is the equation. Okay, so it's taking reactants, adding two reactants together and getting a product. All right, subscripts and coefficients. So this is something now that we're going to start really honing in on, particularly because we're going to start doing something called balancing an equation. A coefficient is going to be a very large number that's written in front of the element. So we see a coefficient there and there. A subscript is exactly what it sounds like, sub, so we're looking below. It's a smaller number that's always written to the bottom right. Okay, so coefficient, bottom right, coefficient to the left of the number, big number, same size as the letter. Subscript, bottom right. Okay, the subscript tells us how many oxygens are bound together. So it's an element of two oxygens. This would be an element of two hydrogens. And then we've got this 2 here. And we're going to talk about in a minute what that 2 means for those the two hydrogens that are bound together. All right, the law of conservation of mass. All this simply means is that matter cannot be created nor destroyed. So in a chemical reaction, we start off with reactants. Now, they may not look like we can see these parts to the plane. I've got these wings here, and I've got the tail here, and I've got the propeller there. It separately, you're like, okay, these look like parts of an airplane. The product is the entire airplane. So in the conservation of mass, it says that whatever I start with over here, I'm going to have over here in some capacity. It may not be exactly the same, but it's going to still be present. All right, so they're not going to be apart like this. They're going to be glued together like that. So if I have the baking soda and I have the vinegar and they mix together, they don't look the same anymore. But the baking soda and the vinegar are still present. Their masses are still present in the product. So I have nothing that has disappeared. Matter, we can't just go poof and have it disappear on us. It goes somewhere. Might be a gas, might turn to a solid, might just stay as a liquid, but it is still there. So when you think about this, I want you to imagine a balance, okay? So if I put in, let's say, 5 grams of sugar, and I add it to 10 grams of baking soda, and I make a reaction, and I ask you, how much should I have in the product? You would tell me I'm going to have 15 because it's how much is over here. So this side has to in some way be equal to this side. Now, it could be that the 5G plus 10G gives me 15G. Or it could be 5G plus 10G gives me 8G plus 7G. It doesn't matter. This is still 15. So the bottom line is, whatever I start with in a reaction, I have to balance it on the other side, and I have to be present in the same amount. Not the same exact way, but in the same amount. Okay? So let's go through and balance equations. Balancing equations tells me exactly how many atoms I need in order to not break the law of conservation of mass. Okay, so we need to be able to balance this out to show you how many mg's I'm going to need to make sure that this actual chemical formula is legitimate and doesn't go against the laws of nature, which would be this law. Okay, so what we're going to do, the first thing you want to do is you want to add up all your atoms. Okay, so what I'm going to do is I'm going to take and I'm going to put how many mg's I have, which is 1, and I have how many oxygens, which is 2. And we're going to only do it on, we're going to kind of divide the equation. So I need the left side, and now I need the right side. I have 1 mg, and I have 1 O. If we look at this, we can tell right away that this is not equal. I don't have the same number of oxygens on both sides, but I do have the same number of mg's. So my focus is only going to be on oxygen. What you do in order to make this balance is you're going to add a coefficient. And remember, the coefficient is the big number in front. You absolutely, under no circumstance, can add a subscript or change a subscript that is present. So as we can see, Mg has no subscript written, which means it's understood to be 1. I can't do anything to that subscript. It's the way it is. This one has a 2. I can't do anything to it. It stays as a 2. The only number I can adjust is the coefficient. We're going to use the coefficient, and it's going to be distributed throughout the entire either element or chemical formula. Okay, distributed meaning multiply. So I have 2 oxygens right here, and I only have 1 over here. I need to say to myself, and now, while I'm doing this, I'm ignoring Mg. I'm only going to focus on one element at a time. I'm going to look at O's. How many O's on one side and how many O's on the other? I've got 2 and I've got 1. I need to put a number right here that when multiplied by 1, because the oxygen's only got 1, will give me 2. So of course all of you are saying, well, Ms. Gebhardt, 1 times 2 is 2. So I'm going to put a 2 right there. That 2 distributes to the Mg and the O, okay? Because Mg and O, they're connected, they're together. So when I look at the right side of the equation, I now have 2 times 1, which is the Mg, and I've got 2 times 1, which is the O. So I've altered my numbers in order to balance my oxygens. My oxygens are successfully in balance. So that's good. But my mg's are no longer in balance. So I'm going to head to the other side of the equation, and I'm going to balance that mg all the way over here. I am distributing a number, something times this 1 to give me 2. And of course you all are telling me 2. So if I look at this, I've got 2 mg's, I've got 2 mg's, I've got 2 O's, I've got 2 O's. This is a balanced equation. Now, you could technically write a 1 in there. It's understood if we leave it blank that it's a 1, but you could, if that makes you feel better to fill the blanks in, you can put a 1 in there all day long. Okay? All right, let's go down and let's do the next equation. So I have aluminum and oxygen, and then aluminum and oxygen. So let's go ahead and add up our stuff. So I'm just counting out the atoms. I've got 2 aluminums and 3 oxygens on the left. Remember, I'm going to kind of divide this up. I've got 1 aluminum and 2 oxygens on the right. Now what do I do? Nothing's in balance, okay? The beauty of a coefficient is I can erase it and rewrite a new one if I need to. So if I put some number in here and I'm not happy with it and it doesn't work, I can come back and erase it. That's the beauty of a coefficient. I can change it when I need to make it work. I cannot have fractional numbers or decimal numbers in my coefficient. It's got to be a whole number, okay? I suggest you start balancing on this particular equation the oxygens first, because the oxygens are going to be a little bit of a pain, because I've got to make a 3 and a 2 equal. How am I going to do that? What do they both have in common? Right now, you should all be thinking, well, 3 times 2 is 6. So 6 is what they both have in common. So if I can make both of my oxygens, these numbers right here, add up to 6, I will balance my oxygens out. I'm only focused on oxygen. I don't care about aluminum right now. I can fix that later. I'm just looking at oxygen. All right, so what times 3, let's go on the left side, what times 3 is going to give me 6? Everybody's going to say 2. So now I'm going to balance my oxygens. I got 2 times 3, which gives me 6. I got to go over here and change my aluminum because now my aluminum is 4. On the right side, remember my focus is only on oxygen. 2 times what is 6? Of course, you're going to tell me 3. So that means now I'm 6. So these guys are successfully balanced. I've got to balance these guys. Well, what times 1 gives me 4? 4. So now my numbers over here, I've got 4 and 6 and 4 and 6. This is a balanced equation. Okay. If you have any questions, we're going to go over this in class. I will actually put up another slide in just a second to give you one more to try on your own, and we will start with that particular and one of those this particular equation in class. But if you do have any questions, please make sure you see your teacher in order to get clarification. We will be doing a lot of practice on this. So if this right here was like overwhelming, don't worry. We will be practicing it. Okay? Just be patient and try to let it sink in a little bit. All right, here's an equation that I want you to try on your own. Okay? Remember, if you get stuck, all you need to do is go through and just start off adding everything up. You want to add up the sides. All right, and we will discuss this in class.